right, so 322 starts the same as 321, looking at those algebra tiles and stuff like that. But as it moves along, we get a nice little shortcut, so which is nice. So anyway, this starts by asking us to get the perimeter and the area. Again, the area is always easier. It's just going to be xy plus, I have two y's there, plus two x's, right? Plus 2, these are 1s. The perimeter, a little bit more of a pain. This is 1. The short side is the x. This is 1. The long side is a y. It's a 1, a 1, a 1, a 1. Uh-oh. I got a little bit ahead of myself there. Sorry. So let's go through this again. This is a 1. Right there is a 1. Right there is a 1, and right there is a 1. This distance, if you look at this distance and this distance combined, I'm just going to call it x minus 2. You can see I have an entire x minus these 2, right? I have a 1 there and a 1 there. A 1 there, a 1 there, a 1 there, and a y, so it's real tight. Anyways, I have 2 x's. My y's, I have 1, 2 y's. The 1s are going to be a little pain to count. So 1, 2, 3, 4, 5. Minus 2 is 3, 4, 5, 6, 7, 8, 9. Looks like plus 9. Honestly, I'm actually curious if I got this right or not. Let me pause it and make sure I didn't miss something. That one right there, the scraggly looking one. So it should have been a 10. My mistake. As I say, 9 didn't make sense because it's like a symmetrical shape, so I would expect it to have an even amount of 1s. But anyway, so moving along, it says you have seen that the area of a rectangle can be written 2 different ways: as a product of its width and its length, and as the sum of its areas. So write the area as a sum and as a product. So at least I'm gonna write it as both. So as a sum, again, I'm just gonna add it up. I have an xy. Here I have an x squared. I have 1, 2, 3, 4 y's. I have 4 x's plus 2 x's, so 6 x's. And then I have 4, 8. And as a product, I'm going to have x here with a 1, 2, 3, 4. In this distance, I have a y plus x plus 2. So I will write this as x plus 4 times y plus x plus 2. And those two will equal each other. All right, so write the area of the as a rectangle as a product of its dimensions equivalent to the area of its sums. Oh, by the way, I guess I could have put an equal sign. These are equal. So here again, I have 1, 2, 3, 4, 5, 6, 7, 8 x squareds. I have 3, 6, 9, 12, 17, 22 x's. And I have 3, 6, 9, 12, 15 ones. And that's going to be equal to 2x plus 3. Hopefully we see there's 2x plus 3 there. And 1, 2, 3, 4x plus 1, 2, 3, 4, 5. So that's equal to 2x plus 3 times 4x plus 5. Now it says, now examine the following diagram. And you can see this looks a lot like this. The only difference is this is known as an area model, and it's a lot less work. And this is that shortcut that I was talking about, right? So instead of putting, all these x squareds in here, and instead of putting all these x's in here and in here and all the ones, right? You don't have to write all that. You can just do a shortcut and say that this equals it. And something I want to point out here that I haven't pointed out yet. Look what 4x times 2x is, 8x squared. So look what 4x times 2x. You can literally see 8x squared. What about 4x times 3? You get 12x. 4x times 3, there's 12x's right there. 5 times 2x is 22x. 5 times 2x is 10x. 10x, right? 22 altogether. So the point being My 22x is these two groups added together, but these two groups are multiplied separately. You can see 12 of them are over here and 10 of them are over here. So kind of interesting the way that works. So this area model I think is a superior way to do it, and definitely a nice shortcut. So let's go ahead and close this and open up part B, and you can see how the shortcut is going to help us as we go through here. So if I look at this, I know that 2x times x is 2x squared, 2x times 5 is 10x, 3 times x is 3x, and 3 times 5 is 15. So what I could say is x plus 5 times 2x plus 3 is equal to 2x squared plus 13x plus 15. I'm just combining like terms there, right? And again, you can see x times 2x is 2x squared, x times 3x is 3x, 5 times 2x is 10x, and 5 times 3 is 15. This right here is known as FOIL. I grew up using FOIL. I didn't use area models. 3 times y is 3y, 3 times 5 is 15, so this will be 3 times y plus 5 is equal to 3y plus 15. Here, I'm going to get negative 7 times 6y is negative 42y. Negative 7 times x is negative 7x. And negative 7 times 1 is negative 7. Here I get 24y squared. I get 4xy. And I get 4y. And again, now the trick is I need to combine like terms. So do I have any other y's? I do. So I'm going to combine all these y's, and I'm going to get negative 38y. I have 24y squared. I don't have any other y squared, so plus 24y squared. I don't have any other xy's, so 4xy minus 7x minus 7. And that's going to be equal to 4y minus 7 times 6y plus x plus 1. So this is an ugly problem, right? There's a lot going on here. But you can still see it's just the side times the side is equal to the middle all added together. Here, x times 2x is just 2x squared. So I'm going to get 2x times x is equal to 2x squared. By the way, I don't know, it doesn't matter if you say this side times this side or this side times this side. Multiplication, 5 times 7 equals 7 times 5. So order is not important in multiplication. All right, so 388, it says diagrams like the one in 387 are area models. Area models represent multiplication of geometric expressions. It's just a nice shortcut to not have to use all the algebra tiles. You're absolutely allowed to use the algebra tiles if you want. I will let you use them on the test. I don't care. I just like the area models because they're a nice shortcut. So let's go ahead and write these again. Now these are already written as the product, right? We know it's the product equals the sum, and they already give us the product. So we can just concentrate on the sum. So x times 1 times x plus 2, I get x squared, 2x, x, and 2. So this will go x squared plus 3x plus 2. I apologize, I kind of wrote that small. Here, we're going to have 3 times 2x plus 5. So I get 6x plus 15. By the way, I want to point something out. Monomials, binomials, trinomials, and polynomials. So anytime you see addition or subtraction, it breaks up into what's known as a term. So here, this is one term plus one term. It's 2 terms. So we have 2 on the side. Here it's 1 plus 1 is 2 terms. So it's a 2 by 2 area model. This only has 1 term times 2 terms. So I have a 1 by 2, right? This was a 2 by 3. So we ended up with 6 boxes. This is a 1 by 1. We ended up with 1 box. A 2 by 2, we ended up with 4. And a 1 by 2, we ended up with 2. So I'm going to start focusing on that a little bit now. So here I have a 2 by 2, right? A 2 by 2. So my area model, which I guess I need to kind of give myself a little bit of room here to go here and write some of this stuff down. But my area model on this one is going to be a 2 by 2 area model. It's a binomial times a binomial. So 2x, one term, negative 3, another term. X is one term, 2 is another term. I get 2x squared, 4x minus 3x minus 6. So this will equal combining like terms, 2x squared plus x minus 6. By the way, don't forget these are all parabolas, right? If I were to graph these in Desmos, this would give me the same parabola as this. If I put y equals x plus 1 times x plus 2, it would equal y equals x squared plus 3x plus 2. All right, so moving along here, this one is a binomial. It's going to be x times -1 times y times -1. I'm going to get xy, negative x minus y with a positive 1. Remember, a negative times a negative is positive. So xy minus x minus y plus 1. Here, monomial, again, addition subtraction breaks it up. So 1 times 2. So this will be a monomial times a binomial. And I know it can be a little bit confusing until you get the hang of it. So hopefully you're feeling more comfortable with it already. So I get negative 2y squared minus 6y. And then finally, this one is a 2 times a 3, right? So I will give myself a little bit more room here and do the binomial times the trinomial. And I will get negative x plus 1 times 3x times y, I'm sorry, plus y times plus -4, so I get negative 3x squared, 3x, negative xy, y, positive 4x, and minus 4. And you can see these are the only two that are combined, that are like terms, right? That 3x and that 4x. So this will equal, I'll just write it down here, negative 3x squared minus xy. Now I'll combine 4x and 3x to get 7x plus y minus 4. And that will be my solution. So hopefully you see the value of an area model in the shortcut. But again, you're absolutely free to use the algebra tiles if you choose.